We've been looking for another Earth our entire lives. Since the first exoplanet was confirmed in 1992, we've catalogued over 5,000 worlds orbiting other stars. 5,000. And in all that searching, we told ourselves the same story. That Earth is the standard. That Earth is the template. That any world worth living on would need to look like us, orbit like us, feel like us. But what if we've had it backwards? What if Earth, right now in 2024, is actually one of the less habitable versions of itself? And what if, scattered across this galaxy, there are worlds where the conditions for life aren't just equal to ours, but better? Today, we're going to the 10 most Earth-like planets ever found. TRAPPIST-1e, Kepler 452b, Proxima Centauri b, Kepler E986f, LH 1140b, Kepler 442b, Kepler 602f, Gliese 600ZSTC, TRAPPIST-1g, Kepler 1229b. 10 worlds that forced us to rewrite what the word habitable actually means. And what we found may be the most unsettling thing in all of astronomy. Let's begin with a question no one asks. What makes a planet habitable? The obvious answer is water. Temperature, atmosphere, the right distance from the right star, a magnetic field strong enough to deflect radiation. These are the basics, the checklist that scientists use to evaluate whether a world could, in theory, support life. But there's a deeper layer. What makes a planet optimally habitable? Not just survivable, but flourishing. In 2014, scientist Dirk Schulze-Makuch introduced a concept called the Earth Similarity Index, or ESI. A score from 0 to 1, Earth, by definition, scores a 1.0. Completely habitable. Perfect. Except that's not quite right. Because the ESI measures the Earth as it is today. And Earth today is not the same Earth it was 500 million years ago. Not the same Earth that hosted the Cambrian explosion, when life erupted in every direction simultaneously. Not the same Earth that was warmer, wetter, richer in oxygen, more electrically active. A younger Earth. Some researchers believe that Earth, in its prime, may have scored higher on its own habitability index than it does now. We are living on a planet slightly past its peak. And some of the worlds on our list tonight might be sitting right at theirs. Start with TRAPPIST-1e. It orbits a small, cold red dwarf star called TRAPPIST-1, located about 39 light-years from Earth. In cosmic terms, that's our backyard. You could point at it in the night sky. TRAPPIST-1e is roughly the same size as Earth. Rocky, likely has a solid surface. It sits in the habitable zone, the region around a star where liquid water could pool on the ground and not instantly boil away or freeze solid. But here's what makes it remarkable. TRAPPIST-1 receives almost exactly the same amount of energy from its star as Earth receives from the Sun. Not approximately, not roughly, almost identically. If you could stand on its surface, and we don't know if you could, the energy falling on your skin would feel familiar. The problem is that it's tidally locked. One side permanently faces its star. The other side faces eternal darkness. A world of eternal noon and eternal midnight, with a thin band of livable twilight in between. And yet, models suggest that with the right atmosphere, heat could circulate. Weather systems could form. That twilight band could be temperate. If that's true, TRAPPIST-1e might be the most Earth-like place we've ever found. If that makes your mind reel, hit subscribe. We go deeper every week. This list is just getting started. Move 1 of 400 light-years away, and you find Kepler 452b. This one hit differently when it was announced in 2015. NASA called it Earth's cousin, a world 60% larger than ours, orbiting a star that is almost identical to our Sun, just a little older, about 1.5 billion years older. Think about that. Our Sun is roughly 4.6 billion years old. Kepler 452b's star is about 6 billion years old. That means whatever life might exist there had an extra 1.5 billion years to develop. 1.5 billion years before humans even appeared on Earth. Life on Kepler 452b could already have passed through every phase we've ever experienced and kept going. Or it could be a warning, because a star that's 1.5 billion years older is also 1.5 billion years closer to expanding into a red giant. The habitable zone around Kepler 452b's star is slowly moving outward. Whatever conditions made that world suitable for life, they're changing, eroding. The window may be closing. We may have pointed our telescopes at a future version of Earth and not noticed. Proxima Centauri b is the one that haunts us most, because Proxima Centauri is the closest star to our Sun, just 4.2 light years away. So close that, in theory, a spacecraft traveling at 20% the speed of light could reach it in roughly 20 years. The Breakthrough Starshot initiative has already begun designing that mission and orbiting it, a planet. Proxima b sits in the habitable zone. It's likely rocky. It could have water. By all basic measures, it's a candidate. But Proxima Centauri is a violent star. It flares, repeatedly, massively. When it erupts, it blasts ultraviolet radiation across its entire system with an intensity that would strip the atmosphere from any world in its path, unless that world had a magnetic field strong enough to resist. Does Proxima b have one? We don't know. We know there's a world. We can even calculate where it is. But whether it's a paradise or scorched, airless rock, we genuinely cannot tell. The nearest potentially habitable world in the universe. And we're not sure if it's dead. Outroller. Kepler 186f was the first confirmed Earth-sized planet found in the habitable zone of another star. When it was announced in 2014, it changed the conversation permanently. Before Kepler 186f, every potentially habitable world we'd found was either too large, too close to its star, or too far. This one checked every box. Earth-sized. Right distance. Rocky, most likely. Its star is smaller and cooler than our Sun, which means the planet orbits much closer, completing a year in just 130 days. But the energy it receives is calibrated. The balance is there. What we can't tell is what the surface looks like, whether it has a thick atmosphere or a thin one, whether its oceans, if they exist, are shallow and warm, or deep and frozen. We see the shadow. We infer the world. We imagine the shore. LHS 1140b may be the most promising of all. It's 41 light-years away, slightly larger than Earth. It orbits in the habitable zone of a quiet red dwarf, quieter than most, meaning fewer catastrophic flares. And most importantly, we think it may have retained its atmosphere. There are clues in how it transits its star, in the way starlight bends around its edges. Early data from the James Webb Space Telescope suggests that LHS 1140bi may have an atmosphere, possibly even one rich in nitrogen, like ours. If that holds up under scrutiny, LHS 1140b might become the first world beyond our solar system where we can say, with something approaching confidence, the conditions for life are present. Not confirmed, not proven, but present. Then there's Kepler 442b, Kepler 62f, Gliese 677c, Trappist 9, Kepler 39 b, each one a variation, each one a different answer to the same question. Kepler 442b scores among the highest on the Earth Similarity Index, receiving about 70% of the sunlight Earth does, cool but within range. Kepler 62f orbits in a wide habitable zone, its year lasting 267 days. Gliese 606cz sits in a triple star system. Imagine sunsets with 3 suns dropping below 3 different horizons. TRAPPIST-1G orbits further from its dim red star, colder, more uncertain, and Kepler 1229b, 770 light-years away, quietly holds one of the highest ESI scores in the entire catalog, 10 worlds, 10 versions of a question we've never quite known how to ask. Now comes the part that stays with you. We measure all of these worlds against Earth. Earth is our 1.0, our perfect score, our anchor. But Earth's score is dropping. Not because our planet is dying. Not yet. Not like that. But because the conditions that made Earth a nearly perfect host for life were most ideal hundreds of millions of years ago. When the atmosphere was richer, when the magnetic field was stronger, when the sun was slightly younger, slightly cooler, the radiation slightly less aggressive. We may be living on a world in gradual decline from its own peak. And out there, at TRAPPIST-1, around LHS 1140, circling Kepler 442, there may be worlds right now sitting at the beginning of their prime, young, stable, with billions of years of peak habitability still ahead of them. If life is out there, it may not be struggling the way early Earth life struggled. It may be thriving, abundantly, easily, and it may have no idea we exist. Tell me in the comments. Does the idea that Earth might not be the best version of a habitable world change the way you feel about our place in the universe? I read every single response. And if this question keeps you up at night, you're in exactly the right place. Because in the next video, we're going somewhere that challenges everything we think we know about where life can exist. It's not a planet. It's something stranger. Keep looking up. The universe is waiting.